Hello, fellow tech enthusiasts. I would like to welcome you to our second course in the Zero to Hero series. Today, we'll explore Terraform. This course is designed for anyone looking to level up their DevOps or DevSecOps skill, whether you are seeking to refresh your knowledge or gain new insights or add a new tool to your resume. You are in the right place. As part of the Zero to Hero course series, we aim to equip you with the knowledge needed to excel in your implementation use case as well as ace any interviews or tackle exam questions. If you have any doubts or if you believe we are overlooking any important concepts, please leave a comment on this video and we will address it. Let's get started with today's topic. We will start with introduction to infrastructure as code and we'll explain what is infrastructure as code. Followed by what is Terraform. We'll dive deep into the Terraform domain. Then we'll compare Terraform versus other available or popular infrastructure as code tools. Followed by we'll understand different Terraform uses patterns. Then we'll dive deep into Terraform architecture, followed by we'll install and set up Terraform. And those will be hands-on section. Then we'll craft Terraform script and we'll build infrastructure as part of the demo. Then we'll discuss about the developer workflow and automation. We'll see how to manage multiple environmental scenarios. And then at the end, as a bonus material, I will take you through a Terraform script for a 3-tier web application. We have a lot to cover today. Let's jump right into it. Before explaining infrastructure as code, let's try to understand the problem statement, what infrastructure as a code resolves. Let's say you have an environment like this. Maybe there is a DNS followed by load balancer, which is balancing the load to application servers. And behind the scene, you have a database. It could be any database engine. And there is a primary, secondary configuration for disaster recovery. Now, normally, you are maintaining more than one environment, one separate environment for development, one for UAT or non-production, and a separate for production. Now, when you are creating all those regions, you are configuring the infrastructure manually. And how about if you are deploying this infrastructure or replicating this infrastructure to multiple regions? And that is a very common use case in today's cloud computing world. And as a result of that, we see a lot of manual configuration work where there is a good probability of human error. You have to validate each and every configuration for every environment. And there is no common standards. Since you are configuring manually, there will be some configuration drift. And last but not least, it is time consuming. To configure a new environment, to set up individual infrastructure and then tiering them together, it takes a considerable amount of time. On the other hand, in today's world, when you look the development use case, a software developer build that code and after that they push that code to version control, where CI/CD kicks in, which builds the code, and then we are deploying that code to non-prod first, followed by the production. While it comes to deployment, we can use the same artifact and deploy into multiple regions without any manual changes. The similar concept applied for infrastructure also. In infrastructure as code domain, we create the infrastructure as part of scripts or code, and we are going to maintain those code in version control. I will cover all those aspects coming from version control to managing multiple environment during this course. But to summarize, infrastructure as code resolve the problem statement where user has to manually create infrastructure. We can create infrastructure with a single click using infrastructure as code script. Infrastructure as code, also known as infra as code. Throughout the session, I will use both the terms invariably. Please do not get confused. Both the terms represent the same thing, the approach to create infrastructure using script. Next, we'll explore what is Terraform. Terraform is an open source infrastructure as code tool created by HashiCorp, and it allows you to define, build, change, and versioning both cloud-based and on-premise resources in human readable configuration file. Let me show you one Terraform script first, but don't worry, we will cover each and every component of the script. This is a sample Terraform script to create EC2 instance. Now, if you concentrate on the red highlighted section, here I have defined AMI, instance type, availability zone. You can add other parameters. Those are optional parameters. Again, availability zone is also optional parameter. When we'll execute this script, it will create an EC2 instance in AWS Cloud. On a high level, it looks like this. I have a Terraform script. If I will execute the script, it will create an EC2 instance for me in AWS Cloud. Now, if you are asking yourself, is Terraform the only infrastructure as code tool? The answer is no. There are different categories of infrastructure as code tool, and we can broadly categorize into two different types. First, by approach and then by tool types. Let's review the by approach side. There are two different approaches. First one is imperative and the last one is declarative. Under imperative type, user specifies the exact steps to be taken for a change. The other category is declarative, where users only need to define the end requirements, and the specific tool or platform handles the step to take in order to achieve the defined requirement. Now let's review the tool types. First is scripts. You can create shell script with the help of AWS SDK to create AWS resources. That is just an example. The next option is you can go for a configuration management tool like Safe, Puppet, Ansible, where you are managing the configurations like you are installing the software, you are installing the dependencies and the packages. Then there is a category where you are provisioning the infrastructure like Terraform, AWS Cloud Formation, Azure Resource Manager, GCP Deployment Manager. Those are some examples of provisioning tool. And the last but not least, there are some tools specifically for container or container orchestrations. And the examples are Docker, Kubernetes. If you are getting confused about which tool to select for what use case and what are the differences, then I have a slide exactly for that purpose. Now let's compare all the tools in one slide side by side. To start with, Terraform and Ansible, those are cloud agnostic. That means if you have a multi-cloud scenario, you can use Terraform to provision infrastructure parallelly in AWS and Azure or AWS GCP or in combination. Similarly for Ansible, whereas if you go to hyperscaler specific tool like CloudFormation, Azure Resource Manager or Google Deployment Manager, you will be able to use for infrastructure provisioning within that cloud. That means with the help of AWS CloudFormation, you cannot create any infrastructure in GCP cloud or in Azure cloud. So if you have a cloud specific use case, maybe you can go to a hyperscaler specific tool. But if you have a cloud agnostic use case, if you want to go for open source, you can choose Terraform. Now, in terms of coding language, Terraform uses HashiCorp configuration language. It's a JSON type syntax, whereas Ansible uses YML syntax for the scripting. CloudFormation supports both JSON as well as YAML. Azure Resource Manager supports JSON, whereas Google Deployment Manager is based on YAML and Python. Now, one important difference that Terraform can track task dependencies. If you have multiple tasks and one is dependent to other, then Terraform or even AWS CloudFormation or Azure Resource Manager, Google Deployment Manager is the best choice for you. If you have multiple tasks and if they are dependent on each other, then Ansible might not be a good option for you, whereas Terraform, CloudFormation, Azure Resource Manager, Google Deployment Manager, they can track the dependencies. If you want to mainly concentrate on infrastructure provisioning, then Terraform is the right tool for you. Whereas if you want to configure infra, if you want to deploy the applications or install or update the softwares or the dependencies, then Ansible is the best tool for you. But if you want to go to hyperscaler specific tool, although CloudFormation on its own cannot do, but AWS has other services. So CloudFormation, Resource Manager, Deployment Manager, with the help of other services like CloudFormation takes help from code deploy, code build, code pipeline to deploy the app, to install or update the softwares, and same as Azure Resource Manager and Google Deployment Manager. If you want to learn YAML or if you want to brush up your skill, we have a separate Zero to Hero series video on YAML, and you can check that. I'll provide the link in the description. Before I proceed further, I would like to request you, if you are new to our channel or haven't subscribed yet, then please consider subscribing to our channel and please click on the bell icon to get notification for any new topics. Now let's continue. In this section, we are going to review common uses pattern. Let's say if you have a use case where you have to provision maybe 4 virtual machines, each in different availability zones, then a load balancer, then databases, then security tools. On top of that, you have a requirement for configuration management. Maybe you have to install software within those VMs, or you have to install the dependencies. Then you can use combination of Terraform and Ansible. Again, these are cloud agnostic tool. You can use Terraform for infrastructure provisioning, whereas Ansible for configuration management. The next pattern is, let's say you already installed those dependencies, you already installed or updated that softwares. Now you want to create a template and you really do not want to repeat these steps each and every time. That time you can create a blueprint for that server. Then you can use that blueprint to configure the next region or next set of servers. For this kind of use case, you can use Terraform in combination with Packer. Again, Packer is another one tool from HashiCorp. You can use Terraform for provisioning and Packer for configuration templating. Then the next use case, it's more specific to containerization. Let's say you want to create a Kubernetes cluster. Maybe you want to configure those underlying VMs with the help of Terraform. But when it comes to container management or container orchestration, then definitely you can combine Terraform with Kubernetes. Terraform will help you to provision the infrastructure, whereas Kubernetes will help you to orchestrate all the containers. And this is again another one uses pattern. Now you can see the provisioning part is managed by Terraform, whereas for other component like configuration management or configuration templating or container orchestration, we can combine Terraform with either Kubernetes or Packer or Ansible. Next, we'll review the Terraform architecture. At the heart of Terraform architecture, there is Terraform core. which is also known as Terraform CLI, which serves as the primary interface for Terraform users, where Terraform users logs and execute all the commands. Then the next component is state file. State file, it is a JSON file that stores information about the resources that Terraform manages, and as well as their current states and dependencies. And then the next component is provider. Now, provider enable Terraform to communicate with a diverse range of services and resources like AWS, Azure, GCP, or other providers. Each provider is responsible for defining the resource that Terraform can manage within a particular service and translating the Terraform configurations into API call specific to that service. Now, if I'll take an example, let's say you want to provision a EC2 instance. In that case, you have to select AWS as the provider. But if you want to create an Azure database, in that case, you have to select Azure as the provider. So whatever the cloud service you are trying to create, you have to select the specific provider. The next part is, let's say you have the DevOps or infra team, and then they have a Terraform manifest file or the .tf file. We will explore the .tf file and the different component, but if you remember at the beginning, I have shown you one .tf file where we have a script for a simple EC2 instance. Now, when a DevOps associate will log into the Terraform core or the Terraform CLI and execute that Terraform manifest file, then Terraform, with the help of the provider, will create that particular resource. Now let's dive deep into the execution process and how Terraform provision those resources. Our DevOps associate or the infrastructure specialist has created the script. The first step would be he or she will log into the Terraform CLI or Terraform core and then init the Terraform core. Then Terraform core will make the environment ready, and after that, DevOps associate will execute Terraform plan command. When Terraform plan command is executed, Terraform core will match the current state. Then it will communicate or create an API request with the help of the provider to understand the current state of the infrastructure versus the state that is provided in the Terraform script. In this phase, still there is no resources has been created. It only planned and it only checks the state and it only determines that what are the things or a summary of steps that it has to perform. Now, after that phase, when the DevOps associate will execute the apply command, that time Terraform will go ahead and create the resource to that particular provider. If you are trying to create an EC2, it will connect to AWS and it will create that EC2 instance. Now, there are two ways you can connect to Terraform CLI. Either you can use your local laptop or your local desktop. If you are using your local laptop, you have to install Terraform in your local laptop. And the other option, you can use cloud resources. That means instead of using your personal laptop, you can use an EC2 instance, and in that EC2 instance, you have Terraform, and from there, you can initiate the infrastructure creation process. For today's demo, we are going to use an EC2 instance, and there we are going to install Terraform. On a high level, this will be the steps for us, and those steps are common no matter if you are using your local environment or EC2-based cloud environment. First, we have to install AWS CLI if that is not available. Then we have to establish authentication within AWS. If you are using EC2-based system, then you will create IAM role. If you are using your local laptop, you will create IAM user. After that, we will install Terraform. Then we will create a Terraform script and we will execute the Terraform script. We will validate if the infrastructure has been created or not, and then we'll destroy the environment because we are doing for the demo and we don't want that infrastructure or the ideal infrastructure to run and incur AWS billing. For today's demo, I will use AWS as the cloud provider. Now from here, let's first review a Terraform script and then we'll directly go to AWS Management Console and we'll perform the demo. Here is a sample Terraform script for you. Now let me explain different components of a Terraform. If you remember the Terraform architecture, there was a component called provider, and that is very important for you to establish that connection. Under provider, since we are going to create an EC2 instance, that is why we have selected AWS as the provider. Under the provider, there are two tabs. One is source, and that will be HashiCorp/AWS. If you are using Azure, it will be HashiCorp/Azure. And then the version number. Followed by, within the provider, we have to select the region. We will perform today's demo into West East 1 region. If you want to follow along with me, you can go ahead and select West East 1 or the region closest to you. Then the main part is the resource, where we are going to define all the resources. If you remember, during the category of infrastructure of code, we talk about two different types of infrastructure as code. One is imperative and one is declarative. Now Terraform is a declarative, and here we are only specifying the end requirement. That is why in the resource, we are mentioning that AWS instance. AWS instance and Terraform will understand that we are giving an instruction to create an AWS instance with this attribute. But if you are in the imperative, let's say if you are going to create in a script-based approach, there you have to define each and every step how to create that EC2 instance. Now let me take you to Terraform documentation and let's review different attributes of AWS instance together. Here is the Terraform registry, and we are reviewing resource as AWS instance. That means everything for EC2 instance. Here is a sample code snippet, but let's scroll down and review all other attributes. Now you can see most of them are optional. We have specified AMI, we have specified availability zone. These are all optionals. If you want to take or pick any other attribute based on your requirement, feel free to choose and add to your Terraform script. But as I told, it is a declarative. Let's say if you use only this part, resource AWS instance, and then full name of the instance, you are specifying AMI. If you want to create in UST2, you will select the AMI ID from UST2. If your region is UST1, please select or change the AMI ID accordingly. And then the instance type as T2 micro. Again, instance type is also optional. If you are not specifying, AWS will create the instance with the best possible values. You can see in the left-hand side, we have all those services. If you want to create CloudTrail, then all those resources along with the attributes, and based on your requirement, you can take the script to next level and add different components. But as I mentioned, at the end of this video, I will give you a 3-tier architecture Terraform script. So my request is please stay tuned till the end. Navigating back to our Terraform script, as we discussed on a high level, it mainly has 3 components. One, the provider. Under the provider, we have the region. That is, again, important aspect in which region you are trying to create, and the resource. If you have more than one resources, you will be able to create within one template. Now let's go to AWS Management Console and install Terraform and continue the demo from there. I have logged into AWS Management Console and I am at EC2 instance dashboard. There I have already one EC2 instance is running. Now let me first start with the authentication parameter. For that, I'll go to IAM. Under IAM, I'll go to roles. As I mentioned, I am going to use an EC2 instance. That is why I need a role. If you are using your local environment, then you have to create an IAM user. Now, if I'll explore the role, let's review all those policies and the permissions. Since my script will create only an EC2 instance, that is why I have given EC2 full access. But my request would be please use principle of least privileges and assign the permission what is absolutely required. I want to make this instance as a SSM managed instance. That is why I have added SSM full access. Now, as part of your Terraform script, if you are going to create other AWS services like load balancer, databases, or RDAs, DynamoDB, S3, please amend proper rules or else your Terraform script will not be executed successfully, or the EC2 instance from which you are running the Terraform script will not have proper privilege to create the resources. Now I'll go back to the EC2 instance. I'll select the EC2 instance. Then from action, I'll go to security and then modify IAM role. And I will assign the role that we have created for this EC2 instance. Update IAM role. Now, first thing, let's try to connect to EC2 instance. I'll click connect and I will use EC2 instance connect option. If you are using any recent AMI, all recent EC2 AMIs are coming with CLI pre-installed. You can execute a command like AWS, then -- version, and it should give you the CLI version. So AWS CLI version 2.14.5, that means CLI is pre-installed. If you do not have CLI pre-installed, then you can go to my channel and there I have dedicated video how to install CLI in EC2 instance or in your local system. You can refer those videos or else you can go to Google and from there you can search install CLI in EC2. And here is the AWS documentation with the step-by-step process for Linux, macOS, and Windows. And that will guide you how you can install CLI in your system or into EC2. Navigating back to Instance Connect. Now the next step, we are going to install Terraform. Let me take you to HashiCorp documentation. If you type install Terraform in Google search bar, the first link is install Terraform and that is the official HashiCorp documentation. Here you will get specific step-by-step process how to install Terraform for Linux, Windows, and macOS. If you are using macOS, you can use Homebrew. If you are using Windows, you can use Chocolatey. And for Linux, I am going to show you step-by-step process. And the other option is you can manually download the binary file and you can install for both Linux, Mac, and Windows. We are not going to do a manual installation. Rather, we are going to follow the steps or the command approach. So I'll go to the Linux tab. I'll go to Amazon Linux. Since my EC2 instance is Amazon Linux 2, I'll copy the first command sudo yum install -y yum utils. And then I'll go to my EC2 instance connect and paste. It's completed and there is no dependencies to install. Then I'll go back and execute the next command. Now we'll use yum config manager to add the official HashiCorp Linux repository. Okay, then I'll go to the next command and now we are going to install Terraform. Copy and paste. Terraform installation completed. It's so easy, right? If you are following along with me and if you are using a different operating system, then please follow the steps for that particular operating system. Install Terraform and then unpause the video and continue with me. We'll go back to the EC2 instance connect. The next step is we will create one directory where we are going to create the Terraform script. Now let me check where I am. I am under home and EC2 user. I'm going to create a directory. So I will use mkdir. I have created a directory, and now I am going to create the Terraform script. For that, I will use y command, and I will use main.tf. For Terraform script, the extension should be .tf. Now I'll click I to insert those script, and I am going to copy the script as is and paste. Now I'll click escape and then :W to save, and then colon WQ to save and quit. I did a small mistake. I have created the Terraform script outside that folder. So let me do again. Let me go back to the folder. And then let's do the same step again. Okay. Now let's check that folder. Yes, inside that folder or inside that directory, I have the Terraform script. Now the next step is I'll execute Terraform init command. I am using the Terraform core or the Terraform CLI, if you remember, and I have initialized Terraform. That is why it is saying Terraform has been successfully initialized. The next step would be plan. And if I am going to execute the plan, that is my command will be Terraform plan. Then Terraform is going to establish a communication with AWS, and it is going to give me a summary that AWS instance.cloudexpert solution demo, that was the name of my instance. If you remember, the name of my instance was Cloud Expert Solution Demo, will be created. It's not yet created. It is giving the plan, and it is giving other attributes like AMI is this, ARN known after apply, because I have specified only instance type, AMI, and the availability zone. That is why all those parameters value has been populated. Others, Terraform will create dynamically. Now I'm good with that because it is saying I do not have an instance there, and that is why it is going to create. The next step would be we have to apply this plan. So again, I'll use Terraform apply. It is asking me, do you want to perform this action? I'll say yes. Now it is saying AWS instance cloudexpert.solution demo is creating. We can go back to EC2 dashboard and we can see the progress. Now I am in EC2 dashboard. If I'll refresh, I should see one new instance is getting created. I'll allow the creation process to be completed. Maybe it will take 2 minutes. I'll pause the video here and I'll come back when the creation process will be completed. It took close to 30 seconds to 1 minute, and now it is in running state. Although the status check is initializing, I would like to show you a couple of items here. We have specified the availability zone as USTist 1A, and we can see that availability zone. Now, if I'll go to details, we have specified the AMI ID, and here is the AMI ID. Also, we have specified the instance type. So instance type is T2 micro. Here is the instance type. So all those variables, what we have specified, or all those attributes, what we have specified, EC2 instance has been created successfully using the Terraform script with those parameters. Now we'll go back to the instance connect option or the Terraform CLI, and we are going to destroy that. And that will give you an end-to-end feeling how to use Terraform and how to create infrastructure using Terraform. Now you can see apply completed, resource added 1, 0 change, 0 destroyed. So once the script will be successfully executed, it will give you a summary how many new resources it has created, how many changed, and how many destroyed. Now our next command will be Terraform destroy, and it is going to tear down the EC2 instance and it is going to terminate that instance. Again, it is asking for the confirmation. I'll say yes. Now the termination process has started. If I'll go back to EC2 dashboard and if I refresh, you see shutting down, and after that it will terminate. Although that script for this demo, I have used a very simple one. I have shown you how to use different providers and how to use different services. Now, my expectation would be you will be able to create Terraform script based on your requirement, and you know the end-to-end process, how to create the script and how to execute that script or how to maintain the Terraform lifecycle. If you are planning to delete manually, then it might not delete all the components it has created. It's better to use Terraform destroy, and it will tear down all the infrastructure that has created as part of the apply process. And now you can see the destroy completed successfully, and it gave that resource destroyed. Let's say you have created a Terraform script and you have created your production environment. That means you have only one region here or one environment here. But in reality, you may have a non-prod or a UAT, and then you have a development region. So for your real life scenario, you have to maintain more than one regions, and every regions will have their own customization, because production will have its own attribute, UAT will have its own attribute, development will have its own attribute. Now let's review how to manage multiple environment. There are two different approaches. Either you can use Terraform workspace concept, or you can go with a Terraform file structure. Under Terraform workspace approach, as the diagram is suggesting, you will create multiple workspaces. However, your main Terraform file will be one. That means you will use the single configuration file for development, staging, and production. Now, how you are going to execute that command? The top level command is Terraform workspace. And from there, if you want to create a new workspace, you will use Terraform workspace new dev. New means it will create a new workspace. Now, if you want to select a different workspace, let's say you are working in the development workspace, you want to switch to staging. In that case, you will execute Terraform workspace select and then the workspace name. Or if you want to delete a workspace, you will use Terraform workspace delete and then the workspace name. While using Terraform workspace approach, Terraform recommends that you should use one workspace for each environment. Like for development environment, there should be one workspace. For staging, there should be one. For production, there should be one. However, if you have multiple different components, let's say under production, you have one Terraform script that is creating only the virtual machines. Whereas for database, you have a separate script. In that case, you have to maintain different workspace for each and individual components. That is why number of workspace will be equal to the number of Terraform configurations and number of environment. Terraform file structure, as the name suggests, we are going to use different directory structure and we are going to maintain different Terraform scripts for each and every environment. Now, the best practice is saying that you should maintain separate file for resource and you should not hard code any variables, or you should not hard code any attributes like AMI ID, region, and all those part. Rather, you should use variable file and you should create a separate file where you can store all the variable values. If you see here, I have the main.tf, that is the Terraform main configuration file. All my variables are defined in the variables.tf, and tf_vars is used to set the actual values of the variable. In my Terraform script, let's say if EMI ID is a variable, then the list will be there under variable.tf and the actual value of that variable will be under terraform.tf vars. Please remember this is a best practice and you can see we'll have this file for each and every regions. Now let's try to understand what is pros and cons for both the approaches. Now as we saw for Terraform workspace, it minimizes the code duplication because you have only one file and you have multiple workspaces. Whereas the cons are all the states will be stored in the same backend. And that is why it is very prone to human error. Moving to Terraform file structure, the pros is obviously its isolation of backends because we are not using any logical steps or the workspaces. Here we are maintaining multiple or separate configurations based on the environments. That is why it is less prone to human error. Whereas the cons is multiple code duplications and multiple Terraform apply you have to use while provisioning the environment. Maybe first you will execute for development region. You will do the Terraform plan and then Terraform apply. Now, if you want to apply the same thing in the non-prod, you have to switch the directory, again go from the start. Again, you have to do the same thing for the production as well. Now, since we are talking about the manual error, when you will create or modify any Terraform script, because this is part of the coding, right? You should do the testing also. Now, let's review the testing aspects of Terraform. What are the different types of testing that you can perform in Terraform? First, compiler testing. Compiler testing is nothing but it checks code syntax and you can use the command Terraform validate. Terraform validate will see all those syntaxes and it will give you an error report. The next is unit test. You have to validate individual component for the Terraform script and for that you can use Terraform test. Again, you can use Terraform CLI for all those commands. Let me show you from my Terraform CLI. I want to validate the syntax, so I'll execute Terraform validate. The configuration is valid. Now, if I want to test it, I will use Terraform test. As simple as that. So you really do not need any other tools to do this type of local testing. The next is integration testing. Now, integration testing means here you are going to create the real infrastructure. As I was mentioning, if you have multiple Terraform script or multiple modules, let's say you have one module for the virtual machines, one module for the databases, one module for the security components, and when you will apply Terraform apply command, it is going to create the real infrastructure and it is going to do the integration testing. Now for those testing, you can use TerraTest. That is another one tool from HashiCorp. We'll explore that part as well. The next testing strategy is linting testing. Linting testing validates code for common errors, best practices, security checks, or even deprecated syntaxes. To use this strategy, you can use tfsec command and Terraform will validate your script using linting testing. Last but not least, drift testing. Under drift testing, Terraform validates the current infrastructure drift from the desired infrastructure state. If I will explain using an example, let's say your original Terraform script provisioned 4 T2 micro EC2 instances. Now in between, you have manually updated the instance type from T2 micro to T2 small. When you will execute Terraform plan command, Terraform will detect the drift, that is the difference between the original instance type and the current instance type. Now, as I was talking about the Terra test, now let's see how you can use Terra test. Terra test is a Go library. Go is a programming language, and that helps you to write and execute automated tests for your infrastructure code, such as Terraform, Packer, Docker, Kubernetes. The first step is you have to write the test code using Go, the similar way you are writing JUnit test script for Java code. The next is you have to use Terra test to deploy the infra. That means you are deploying the infrastructure, you are validating if each and every component is deployed successfully, and you are doing the integration test. And then you are going to initiate the infrastructure validation process with Terra test, and everything will be combined as part of that. And at the end of the validation, once everything is validated, what you are going to do, you are going to undeploy the infra. So this will be part of the Terra test. Now let's see how you can integrate Terra test, or how you can automate all those stages without doing any manual work. The first part of the process, let's say you have Terraform developer who are creating or modifying the Terraform manifest file or the main.tf file. Once the developer completed, first they will perform compiler test the way we did Terraform validate, Terraform test, and then once everything is working fine, then he or she will push that code to Git repo, and then the Git repo will auto trigger a unit test. Again, you can create those unit test scripts using Terra test. And then after that, once everything is successful, you can create a pull request. Once the pull request is created, it can trigger the DevOps CI/CD process. And as part of the continuous integration, it will initiate the Terra test, where you have the automated testing script. So first, it will deploy the infra, it will validate the infra, and once everything is validated successfully, then it will undeploy the infra. You can put a check gate here. If everything is completed successfully, then you can initiate the deployment to the stage region. And once everything completed successfully, you can add a manual approval state, because you really don't want your production infrastructure to go up and down as soon as developer will push that change. Now, once the approver approves that request, it can go ahead and deploy that change to the production. And by this way, you will be able to automate end-to-end process, starting from infrastructure script creation to infrastructure deploy. Now we are almost at the end of our session, and as I promised, now the time is and take a more complex Terraform script to explain different component in that script. I'll go back to my IDE or the VS Code editor, and I have a Terraform script called simple web app.tf. The first section is provider, that is same as the EC2 instance, and I have AWS provider. And once you put that hashtag, that means this is a comment. Now the same code block here, the source is Hasikoff AWS, and there is a version number. And then again, the region I am using UST1. The first part, I am creating two web servers in UST1. Now this is the web server 1 and this is the web server 2. I am selecting the AMI instance type, and then I am using user data also, because I want to create as a web server. That is why I am putting an index.html as well. Then I am going to use the default VPC. You can see that AWS VPC and default is true. But if you want to use or create a custom VPC, then obviously your step would be defaults as false, and you have to put all other attribute from the Terraform repository. Now we are creating the subnets and followed by the security group. Now in the security group, we are creating the group ID and all those rules. So you can see the type is ingress. From port is 8080, to is 8080, that is a TCP protocol, and the CIDR block allow from all. Coming back, we are creating a load balancer, and here the port is 80, protocol is HTTP, and we are setting a default response also. To set the default response, you can create a default action, and there we are putting a fixed response and sending HTTP 200 code. And then I am creating a target group with a health check. Now health check, again you can see that I am checking that path, protocol HTTP, looking for the HTTP 200, interval is 30 seconds, timeout is 5 seconds, healthy threshold 5, unhealthy threshold 5. So whatever you are configuring manually, we can configure using Terraform script. Now the target group, and then followed by the load balancer listener rules. So now you can see these are pretty much descriptive, and that is self-explanatory. And I feel that you really do not have any problem to understand what the steps are actually doing here. Now here I have the security group ingress rule, where I have from TCP from port 80 to protocol TCP, and to port is 80. And I would like to show you one more point. Yes, the protocol. Protocol -1 mean allowing all. If you are using specific protocol, then you will use IP protocol as TCP, RDP, SSH, or if you want to open for all, you will simply use protocol equal to -1. I believe you are more confident now to create your infrastructures using Terraform scripts. You know how to install Terraform, Terraform lifecycle, maintain multiple environments, and test your infra as code scripts. For script syntaxes, please refer the Terraform registry, and don't forget to use Terraform destroy command when you want to tear down your infrastructure. This was all for today. If you like our effort, give us a thumbs up, and please share this video with your friends and families. Subscribe to our channel and click on the bell icon for more content like this. Thank you for watching.